Okay, back to code. Okay, so joysticks here, open close brackets here, index dot num buttons equals SDL underscore joystick num buttons, open parentheses joystick, close parentheses, semicolon, and this is the number of buttons on the joystick. And this command from SDL goes out and gets that number for the joystick that we have opened, and it's going to reply with it and store it into our wonderful struct value here inside of our vector. Okay, so now we have the number of buttons. So guess what? Now we have the number of buttons. We need to, guess what? Resize our button vector so that way we can store all the values of those buttons being pressed in gameplay. So joysticks here, open bracket, index, close bracket, dot, button, dot, resize, open parentheses, joysticks, open bracket, index, close bracket, dot, num buttons, close parentheses, semicolon. Okay, so here we're taking the number of buttons for the controller, and we're resizing how many buttons we have in our vector. And don't do what I just did. Apparently I can highlight and move code. That's cool. I can do that. It's just not very useful when I don't want to mess up my code. Printf here, again, I'm just doing this for testing purposes. Open parentheses standard out, comma, quotes num of buttons here, and then %d / n, close quotes, comma, space, joysticks, open bracket, index, close bracket, dot, num buttons, close parentheses, semicolon. Okay. With this, it will actually tell me how many buttons are on my joystick. Number of buttons. On my controller, gamepad controller, there's 12 buttons. So quite a few, actually. And then I can store in the values of 1 or 0 as to whether or not it's been pressed. Very cool. Alright, joysticks, open bracket, index, close bracket, dot, num hats equals SDL underscore joystick, num hats, open parentheses, joystick, close parentheses, semicolon. So this opens up for our joystick that we have opened up. And so for that, we're going to get the number of hats, hat controls, using the SDL command underscore num, joystick num hats here. And that's going to get all the hats that are for this current joystick that we have open. And it's going to assign it to our num hats in our data array, in our vector array, if you will. And as you probably imagined, guess what we need to do? Yes, that's right. We need to resize our vector for our hat. So joysticks, bracket here, index, close bracket, dot, hat, dot, resize, open parentheses, joysticks, open bracket here, index, close bracket, dot, num hats, close parentheses, semicolon. So here we are. We're going to be resizing with our total number of hats for this particular joystick to the resizing our hat array to handle that number of vector elements. So that way we can access them later on in runtime. Okay, very cool. Then we're just going to do a fprintf here, open parentheses, std out here, comma, quotes, num of hats, %d here, /n, close quotes, comma, joysticks, open bracket, index, close bracket, dot, num hats, close parentheses, semicolon. Okay. And again, that's just going to display out into our file the number of hats. In my case, I have 1. And I have 0 for the balls. So my controller doesn't have any balls. Alright. So joysticks here, open bracket, index, close bracket, dot, num balls equals SDL underscore joystick num balls, open parentheses, joystick, close parentheses, semicolon. Okay. So this is the SDL's command to go out and find out whether or not your joystick controller has balls. And if it doesn't have any balls, then it's going to come back with nothing. In my case, I have no balls for my controller. So there'll be 0 will be passed into mine here. So, but if there are multiple balls on a controller, which I don't think hardly have, usually only have 1 ball, you have your joystick here, open bracket here, index, close bracket, dot, ball, dot, resize, open parentheses, joysticks, open bracket, index, close bracket, dot, num balls, close parentheses, semicolon. So basically we're resizing our vector again for the balls here, for the ball, how many balls it has, and based on the number of balls, of course, for our vectors. So that way we can use it in runtime. actual execution of the game. So fprintf here, open parentheses, standard out. Again, this is for debug purposes and testing, comma, num of balls here, %d /n, close quotes, comma, joysticks, bracket, index, close bracket, dot, num balls, close parentheses, semicolon. Alright, SDL underscore joystick, close, open parentheses, joystick, close parentheses, semicolon. We opened up our joystick up above here. Now we need to close it. And the only thing we pass to it to close it is the actual joystick itself. So that way it knows what thing to close from memory. Alright, and then I did fprintf std out, comma, in quotes here, /n, close quotes, close parentheses, semicolon. Again, only for testing purposes. And this makes it nice and neat, so that way every time we get something displayed to the text file here, there's a double enter sign, double enter key basically pressed, if you will. And this helps break up spacing out your text, so it makes it easy to read between different controller inputs and such. So that way when you're testing stuff, you actually know what on earth it was that you were passing in here or there, or what was happening. So that way you can tell one joystick from another and what input and what's going on. So it makes life easier, let's put it that way. Close curly brace, close curly brace, close curly brace. Okay, that was just initializing the controller, but it got us set up. Okay. Now to get the actual information coming from the joystick for each joystick and what's going on, so we can use this to drive our game in whatever way. Now you could also set this up with a configuration window where you're buying different actions to different attributes of a controller. So that's ideal, of course. Okay, so here we are. We have void get joysticks, open parentheses, void, close parentheses. Open curly brace, for open parentheses, int, index equals 0, semicolon, index is less than num of joysticks, semicolon, index plus plus, close parentheses. So we still have the number of joysticks we have. So we know how many joysticks we need to loop through when we're checking for our joystick input each frame, okay? And of course we need to loop through each joystick, especially if we have multiple players. Makes sense. Joystick equals SDL underscore joystick open here, open parentheses, index, close parentheses, semicolon. So we're going to open up a joystick, again, just like before. Why? Because we need to get the values from it. So we always have to open the joystick if we're going to get values from it. Always makes sense. So we have to tell it which one we need to read from when. Cool part, since we're looping through each joystick again, of course, we only open each one that we're accessing at the time we're accessing it. So we can't access all joysticks at the same time, basically is what I'm saying. You can only access them one at a time. SDL underscore joystick event state here. Open parentheses SDL underscore enable, close parentheses, semicolon. Again, you must enable the joystick event state, otherwise you will not get any information from from SDL on the joystick, even if your joystick has been opened. So you must also enable it. You cannot enable your event state for that joystick until that joystick is opened. So you must have the joystick open first, and then you can enable it. So it needs to be done in this order. I did indent, because this is like a begin and end type set of statements here. So be sure to do that too for clarity and simplicity for reading back your code. Okay, so for here space open parentheses int space index axis equals 0, semicolon. This is the index axis. Alright, index axis. Here is less than joysticks index here dot num axes, semicolon, index axes plus plus, close parentheses. So now we're going to loop through all our axes here, and we're going to get the values for them for each joystick. So open curly brace here, joysticks here, open bracket here, index, so we get our current joystick that we're working with. Close bracket dot axes, open bracket, index axes, close bracket, so current axes that we're accessing. SDL underscore joystick, get axes here, open parentheses joystick, comma, index axes, close parentheses, semicolon. So for our current joystick, we're going to get our current axis that we're on in the loop until we loop through all the axes for this particular joystick in this loop, which will loop through each joystick throughout this outer loop here. So basically this will get us all the axes for all the joysticks. If you need to see your input to make sure everything's going right, use this fprintf statement here for testing purposes. I've commented it out because once this stuff starts going, you're going to not want to run your game for very long, because it's going to just start filling up that standard out file very quickly with text, because it's going to be reading in from every frame on this controller very quickly. So //fprintf here, open parentheses std out, comma, in quotes, axis %d colon value %d /n quotes, comma, index axes, comma, joysticks, open bracket, index, close bracket, dot axes here, open bracket, index axes, close bracket, close parentheses, semicolon. And then that's going to display out the axes, which axis that you're accessing, and the value on that axis. So that makes a lot of sense. This is really useful for debugging purposes too, when you're trying to figure out gameplay and what's going wrong or something with your gameplay. Maybe on your player character or something like that, for its logic. Okay, close curly brace here. For open parentheses, int, index button equals 0. So now we're going to get all our buttons. Index button here, less than joysticks, open bracket, index, close bracket, dot num button, semicolon, index button, plus plus, close parentheses, open curly brace here. Joysticks, open bracket, index, close bracket, dot button, open bracket, index button, close bracket. So for our current joystick, our current button, equals SDL underscore joystick get button, open parentheses, joystick, comma, index button here, close parentheses, semicolon. So get the particular button for the particular joystick we're working with, for the particular button we're working with from SDL from the game controller, and assign that value, if it's been pressed or not, to our button value for that controller. Alright, you can also do an fprintf for this one too. So let me just move this over real quick. Comment it out, but it'd be fprintf. Here, open parentheses std out. Again, it's only for testing purposes, comma, in quotes, button space %d colon value space %d /n close quotes, comma, index button, comma, joysticks, open bracket, index close bracket, dot button, open bracket, index button, close bracket, close parentheses, semicolon. Alright, and that gives us tells us what button was pressed on the controller, and was it well, it tells us what button it is and if it's been pressed or not. The value is whether it's been pressed or not. It's going to be either a 0 or 1, 0 being not pressed, 1 being pressed. Okay, close curly brace for int, for open parentheses int space index hat equals 0, comma, index hat is less than joysticks, open bracket, index, close bracket, dot num hat, semicolon, index hat, plus plus, close parentheses. If you're smart, you'll copy and paste the first one and then make changes as needed for each one of these. Close open curly brace here, joysticks, open bracket here, index, close bracket, dot hat, open bracket here, index hat, close bracket, space equals, space, SDL underscore joystick get hat, open parentheses, joystick, comma, index hat, close parentheses, semicolon. Alright, so for the current joystick we're on and the current hat that we're accessing, get the hat value for that current joystick for the current index from SDL. So this is getting it from the SDL command from our joystick, and this assigns it to our actual value for our data array, so that we can actually do something with it. Alright. Now we also have an fprintf for this one too. So fprintf here, I commented it out because it's only for testing purposes. Open parentheses to std out, comma, quote, in quotes here, hat space %d colon value %d /n quotes, comma, index hat, comma, joysticks here, open bracket, index, close bracket, dot hat, open bracket, index hat, close bracket, close parentheses, semicolon. And that gets us going for that, for our output there. Close curly brace here. And if, open parentheses here, joysticks index here dot num balls is greater than 0, then, so we're saying if we have more than, 0 balls here, then we need to do something about it. I don't want to process this statement for execution speed if we have no balls, basically, for our controller. Open curly brace here for, and then space here, open parentheses, int, index ball equals 0, semicolon, index ball is less than joysticks, open bracket here, index, close bracket, dot numBall, semicolon, index ball plus plus, close parentheses. So we have our index for accessing each ball. Curly brace here, int joy ball success equals SDL underscore joystick get ball here, open parentheses here, joystick comma index ball comma ampersand sign joysticks open bracket index close bracket dot ball open bracket index ball here close bracket dot x, and then same thing again. It's going to be ampersand joysticks open bracket index close bracket dot ball open bracket index ball close bracket dot y. Okay, what is all this? And that's close parentheses semicolon, of course. Okay, so were we able to actually get the information for the ball? True or not? True or false on success here? You know. So that's important here. If it's 0, then we have success, and I'm displaying out those values here. Otherwise, if it's not 0, if it's like a -1 or something like that, then we're unable to get the ball values. So, you know, needs to be a 0 for success here for the statement. SDL underscore joystick get ball is how we're going to get that ball action here. This is for our current joystick. This is for the index of which ball we're accessing. This is to come back with the value stored in our array for x, or into our vector, shall I say, for x and for y here, okay? And so for passing this in through relative, it gets set with inside this SDL function and comes back with the values in x and y, okay? After this thing, from a successful execution, of course. Here I say if joy ball success equals 0 here, then say an fprintf std out comma in quotes ball %d colon x space %d you know, and then y %d here. So for which ball it is, here's our x and our y values. Okay, comma and that's in quotes here, comma index ball comma joysticks open bracket index close bracket dot ball open bracket index ball close bracket dot x comma joysticks open bracket index close bracket dot ball open bracket index ball close bracket dot y close parentheses semicolon, and this gets us all our values to fill this out. Else here fprintf sorry open parentheses std out comma in quotes unable to get ball values, you know, exclamation marks slash in close quotes close parentheses semicolon close curly brace close curly brace. Okay, so that takes care of our balls. Alright, so over here we have SDL underscore joystick close here open parentheses joystick close parentheses semicolon, and that closes our current session to this particular joystick, so that way we can end up looping through it later. Currently I'm applying these values from this that we got from this information when we were accessing joystick to then drive my if statements here. In my case, I know I only have one joystick, so I just coded it out for one joystick by putting in 0 here. So I said if ABS open parentheses joysticks here bracket 0 close bracket dot axis open parentheses open bracket 1 close bracket close parentheses is greater than 3000 close parentheses. Okay, so how does this work? Now realize our axis here on x-axis could be you know, dead center of the joystick here, it would be 0, right? But if I pushed it to the right, that would be a positive, like, I don't know, 34,000, 36,000, you know, something like that. And I push it to the left, it'd be like negative 34,000, 36,000, whatever it is. So That's quite a bit of values there. It's quite high. Ideally, we want to be able to control, you know, some kind of offset. So what if the joystick doesn't go quite perfectly back to dead center again? Well, if that happens, then basically this joystick is always going to be active, right? So you're always going to have some kind of floating movement to it, and that's going to be annoying. So what we want to do is make the joystick appear very responsive, but we don't want it to be activating when someone's not touching it. You know, or heaven forbid someone puts their thumb slightly on the joystick and barely moves it and then starts making something spin, you know, or activate. That's annoying. We do want a slight touched feel to it, but we don't want it to be so slight that just putting your finger on the joystick is going to activate, you know, something. So we want a range of precision where you want a dead zone, basically, range. So 3000 to negative 3000 works. If I take the absolute value of whatever value is from that axis there, then it's going to take a negative to be positive, and a positive is going to be positive always. So now I can get away with a simpler structure here for my if condition statement with just using. That's why we included that map library earlier, so we could do the ABS function here. And this makes it life easier for doing this test here. So we're only going to apply the values from the first axis here, from axis 1, I mean, which is not the first axis, but rather the second axis. For joystick, 1, if it's above 3000 or below negative 3000. So we have that center line dead zone right between, left and right, where someone can barely move it or can be barely offset on the position on the controller when it comes back, and it not affect our game. So we do want that dead zone there. You can even make this as a variable to be set for that dead zone for sensitivity if you want, for joystick sensitivity. And you can set that value so people could turn it up or down to whatever they need to for their joystick value. But for now it's 3000 is what I'm using, and that's worked out very nicely for me for most circumstances. So you can feel free to play around and test your stuff out, but I found 3000 to work really nicely. Okay, so rotate X here plus equals joysticks here, and then open bracket 0 close bracket dot axes open bracket 1 close bracket. So again, first joystick, second axis, times 0.001 times 0.05 semicolon. Now you can set these speeds up however. I had to use some fairly high, really small numbers here and multiply it through in order to really massively reduce these values. Otherwise, if you have like 36,000 times whatever your units are, you're going to be spinning like so fast, it's going to be ridiculous. It's going to be totally unusable. You might as well just forget it. So I want to make this more manageable. And of course, the more someone, with the way this is set up, the more someone pushes a joystick in any particular direction, it's going to actually make it accelerate and move faster or move further. Okay, so with that set up, we do have acceleration capabilities inside of our functionality here for our joystick. We just don't want it to be overwhelming, basically. So if parentheses ABS here, open parentheses joysticks here, open bracket 0 close bracket dot axis open bracket 0 close bracket. So say in the first joystick, first axis, open is greater than 3000. Again, that's that dead zone we're talking about. So now we're talking about up and down on the stick here, and we're going to be talking about rotate Y. Well, actually, we're going to be doing rotate Y. This is side to side, and this is up and down here. So our axis 0 is going to actually be side to side, but whatever. Plus equals here, joysticks, open bracket 0 close bracket, this first joystick dot axis here, open bracket 0 close bracket, and that's the first axis, times 0.001 times 0.05 semicolon. Again, that was to help deal with the speed. And then if you want, you can also do, I've also commented this out too for doing the formatting, because I didn't see a need for it anymore, since I have the others commented out too for the F. But you want to do fprintf here, open parentheses std out, comma in quotes here, /n, close quotes, close parentheses, semicolon, and again that's for a nice formatting. Close curly brace, close curly brace, and so that accesses our joystick. And just to show that it works, I am now controlling my cube with my joystick. Push it right, it moves right. I push up, it moves up. I push down, it moves down on my stick. And so it's all moving very easily. You see my mouse is up here, and so I'm totally not manipulating this with the mouse. I'm also not pressing the keys on the keyboard either. It's definitely the joystick all the way. And here's a very slight movement with my joystick here. Versus, and then I'm going to start pushing it further, 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 further. Notice how it gets faster now, right? And I can control the speed of it. That's not something you can do with keys. This is only possible to do with the joystick, the way I'm doing this right now. There I am pushing at full speed here, and then slowly move my stick back to center. And you can see how we have that range of speed motion here. I start pushing it further and further, further up. There you go. Back. And so on and so forth down too. So very cool. And you can set up a certain button if you want on your controller to exit the game too. You could do that if you like. Maybe like, I don't know, like your button's like 10 or something like that on your controller. Should be more like a normal start button would be on a controller. I could set that up. You could set up one of the sticks to zoom in and out if you like. That'd be totally possible. If I wanted to, I could set that up to make the joystick zoom in and out. It'd be easy to do. You know, feel free to play around and do your own stuff if you like, and add some extra functionality, and that'd be cool. And it'd certainly be easy to do. You just kind of do exactly what we just did here. So you know, and I'm applying these values from each joystick here. So I do have to do this for each joystick going through here. In this case, though, I have already kind of preset this thing up. So actually, since I'm just kind of hardcore grabbing it, I mean, the nice thing to do would be put index in here, right? Yeah, I guess so. That'd be the best thing to do. So that way it corresponds with this thing up here. So that way it'd handle it for all the different controllers. For whichever controller you grab would actually affect it and manipulate it. Okay. So there it is. Now it's coded out for multiple controllers. Yeah, and all I did was just add in that index, you know, here and here. So it decides it for which controller it is. You know, obviously I can sit here and loop through each of the axes values or something like that, but anyways, this is pretty procedural and pretty dynamic as it is for the most part. I just hard coded in a few values here just for demonstration test purposes. Up to you what you want to do. You can really do anything that you want with the joystick system now at this point, because you basically have written a full-blown joystick system to do whatever it is you need. With that said, we need to actually initialize the joystick subsystem. And you're probably going, well, why didn't we have to initialize the mouse and keyboard subsystem? That's because they're actually part of the video system, believe it or not, and they're part of the main SDL setup here for initialization. So when you initialize the video, you're actually initializing also the keyboard and joystick that come along for the ride. Joystick's not that way. Joysticks is a totally separate subsystem, and so it doesn't go along with the SDL main. So we have to initialize it separately and check for errors here. So I've said over here, unable to initialize SDL video, so we know it's a video problem. And over here I said SDL joystick, so I know it's a joystick problem if there's a joystick error. So if here SDL underscore init subsystem, now that's different. Yes, you need to say subsystem because this is a subsystem of the SDL. This also means you can shut down the subsystem without shutting down SDL itself. So that is possible. So SDL underscore init subsystem close open parentheses SDL underscore init underscore joystick close parentheses, is less than 0, close parentheses. So if we get something other than 0, like a -1, then we have an error. So fprintf here, open parentheses to std error, comma, space, quotes, unable to initialize SDL joystick here, %s for string basically. Close quotes here, comma, SDL underscore get error, open close parentheses, semicolon. Alright? And that lets us get the error from SDL and display it here. Exit here is 1, open curly brace. I could have made that a 2. Oh well, I didn't. I made a 1. Same thing here for our set video mode. Same thing as before. Nothing new there. Our init GL hasn't changed at all. Our init joystick here is the new one. So we need to initialize our joystick before we dive deeper into the other parts of this setup here. So we do need to do that before we go into our while loop. Reason why is we don't want to continuously initialize our controller. That would be insane. We only want to initialize it at the beginning of the game and not again unless there's a need for it. So I'm not wanting to assign that every frame because that would be incredibly inefficient to do so. So bool done equals false, semicolon. While parentheses, exclamation mark, done, close parentheses. So this is the same. Draw the scene, still the same, still the same, still the same. SDL key down. If it's down, it's true. Same, break. Okay. We'll get over here to our mouse button up. I commented out this stuff for printf here. And I'm just setting it as true or false here. It doesn't matter. I commented out all the stuff for the rotate. So all functionality as far as left and right mouse button are being pressed or whatever is no more. We just comment all that stuff out because we don't want to actually do that. We want to actually handle that through our direct method here. If we don't uncomment this, then we can't see the effects of our direct method. So it's important to comment this out. I commented out all the other parts here for everything from the mouse motion to the left mouse button being pressed here, and then we just have our SDL quit here, and then also we have our SDL case SDL underscore joy axis motion here, quote here, fprintf standard std out, comma, quotes, joy axis moves, /n here, quotes, close parentheses, semicolon. I wanted to show you how you do joystick interaction here, basically, in polling method. So this is an example of how you can do it in polling method. I'm not a fan of it though. The one I really like is the direct access, so I just did everything else direct access. But just to show you, this is how you do it. Break, semicolon, open curly brace, close curly brace, keyboard, open close parentheses, semicolon for direct access for our keyboard. So we directly access our hardware, directly access our mouse, and then directly access our joystick, which is the get joystick function we just did earlier. Close curly brace here, SDL quit, open close parentheses, semicolon, return 0, semicolon, close curly brace. And that is the entire program and how it works. Okay, that was a long one. Alright. Well, that covers how to do joystick, mouse, and keyboard direct access with SDL, how to set up a joystick, how to auto activate, how to get everything to automatically set up and work. And this has been OpenGL and SDL programming. My name is Nate Nestler, and this is for Hyperactive Studios. Thank you very much.